right, everybody. Today we're going to be doing lesson 7-5, our last lesson of the book. Determine outcomes of compound events. I know some of you are thinking, Mr. Mendez, there are two more lessons in the book. No, we are ending the book on lesson 7-5, and we will be reviewing for the rest of the year different things that we need for 8th grade, and that information should be going out in the other packets. And when I go ahead and make new assignments on Microsoft Teams. So let's begin. On the Explorer, it says Cameron packed 2 pair of shorts and 3 t-shirts for a weekend trip. What are some of the combinations of shirts and shorts that Cameron can wear while on his trip? How many days will he have a different outfit to wear? We can see here that he has a yellow shirt that he could wear with green or blue shorts. He has a white shirt that he can wear with green or blue shorts, and he has a red shirt that he could wear with green or blue shorts. That's going to give us 1, 2, 3, 4, 5, 6 different combinations. Hopefully, Cameron has a washing machine to make sure that all these things are going to be clean. Let's focus on the max practices. How would the number of different outfits change if Cameron packed a pair of khaki shorts? Explain. Well, let's think about what happened last time. We had 1, 2, 3 shirts and 2 shorts. Well, we could say that 1, 2, 3 times 2 gave us 6 different options. This time we have 1, 2, 3 times 1, 2, 3 different shorts. That's going to give us 9 different options. Let's see if that works out. As we can see here, it says Cameron would have 3 more possible outfits. He could choose to wear any of the 3 t-shirts with the khaki shorts. So the 6 outfits we had before plus 3 more make 9. Looks like it worked out just fine by using simple multiplication. An example 1, I think we have here. Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family with 3 children that the children will be all boys or all girls. How can they determine all possible combinations of boys and girls in a family with 3 children? Well, first of all, we can remember that we could list the different events. First of all, we got child number 1 will be either a boy or a girl. Child number 2 will either be a boy or a girl. And child number 3 will either be a boy or a girl. This is called a compound event. Compound event consists of 2 or more events. This compound event consists of 3 events. 1, 2, 3 events. 3 kids being born. Step 2, make a tree diagram to represent the sample space. Remember, the sample space are all the possible outcomes. A tree diagram shows all the possible outcomes. We've got child number 1 either being a boy or a girl. And of that child, the next one would either be a boy or a girl. And then again, child number 3 would either be a boy or a girl. So the chances that it would be all boys would be, well, boy, boy, boy would be 1 out of 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. Boy, 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 or girl, 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 it's going to be 1 out of 8. So Haley and Josh can make the tree diagram to show the sample space of boys and girls in a family tree with 3 children. Now we're over here with the triad. It says George will flip, or it looks like Jorge, will flip 2 quarters at the same time. Complete the tree diagram and then list the sample space of this compound event. Use heads, or H for heads and T for tails. Well, here we see we've got heads or tails on the first flip. On the second flip, it's going to be heads, or you guessed it, tails. And on the third, on the flip over here, what could have been tails is either going to be heads or tails. So the sample space is heads, 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 tails, tails, heads, and tails, tails. That's 1, 2, 3, 4 different possible outcomes. How does the sample space change when the number of quarters that Jorge flips is increased by 1? Remember, we're not going to be flipping 1 quarter, or we're not going to be flipping 2 quarters anymore. We're going to be flipping 3. Well, look at over here. When we had 1 quarter, it multiplied and made two different options. Well, those two options made two other options, so we doubled it, which means we're going to have to double these options when we get 3/4. So this is going to be heads or tails. This would be heads or tails. This would be heads or tails, and this would be heads or tails. So this would be 4 times 2, which should give us 8 options. It says here, each time the number of quarters flipped is increased by 1, the sample space doubles. There are 2 possible outcomes when flipping 1 quarter, 4 possible outcomes when flipping 2 quarters, and 8 possible outcomes when flipping 3. Use a table to represent the sample space. A game is played by spinning the 2 spinners shown. Players matching the results of the spinners, 2 combinations of their game card. How many different combinations are possible? Well, let's look at these game cards here. And remember, we're trying to find all the combinations. All right, it says a game is played by using 2 spinners. Players match the results of the spinners to the combination. So this would be like spinning B and then 1. So it's kind of like a bingo game, you would say. All right. So how many different combinations are possible? How many do we have here? 1, 2, 3, 4, 5, 6. And how many do we have here? 6. Well, you might have guessed it. Use a table to represent the sample space. Remember, the sample space shows all the possible outcomes. This is going to be 6 possible letters combined with 6 possible numbers. That's 6 times 6. And that's going to give us 36 possible outcomes. Stan will roll a number cube landed 1 to 6 and flip a coin. Okay? Labeled 1 to 6 and flip a coin. So that gives us 6 options here, and a coin gives us 2 options because that's either heads or tails. What are the possible outcomes? Well, that's 6 times 2. Use the organized list to represent the sample space. Well, as you guessed it, 1 could roll, and then it would be heads or tails. 2 could roll, could be heads or tails. 3 could roll, could be heads or tails, and so on. This is going to be 6 times 2, which will give us 12. 12 possible outcomes. The triad says a bag contains tiles labeled with the letters A, B, and C. The box contains tiles labeled with numbers 1, 2, and 3. June draws a 1-letter tile and 1 number tile. Represent the same space, the sample space using either a table or an organized list. Well, it's very easy. It could be an A or a 1, an A or a 2, and an A or a 3. It could be B or a 1, B or a 2, or B or a 3. It could also be C over 1, C and 2, and C and 3. So that's very simple. 3 times 3, that's going to give us 1, 2, 3, 4, 5, 6, 7, 8, 9 different samples, sample spaces. So we're off to our key concept now. Key concept says a compound event is a combination of 2 or more events. An organized list, table, or tree diagram can be used to represent the sample space of a compound event. The sample space for flipping 2 coins consists of 4 outcomes. And we can see that using an organized list. It could be heads or heads, heads and tails, tails and heads, tails and tails. We could use a table. We have heads and tails over here and heads and tails over here, which gives us heads, 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 tails, tails, heads, or tails, tails. Or we could use a tree diagram, which gives us heads, tails, and then each of them branching off to heads, tails again. Once again, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 different possible outcomes. Let's go to the do you understand? It says here, how can all possible outcomes or sample space of a compound event be represented? Well, you can make an organized list, a table, or a tree diagram. We just went over that, right? Next one. Will a list, a table, and a tree diagram always give you the same number of outcomes for a sample compound event? I think not. But it says yes, the displays are different ways of showing the same sample space. Oh, I get it. This simply means no matter which one we use, we're going to get the same amount of sample of the compound events, right? The same number of outcomes. Well, that makes more sense now. Number 3, Sherry is drawing a tree diagram to represent the sample space of rolling a 12-sided game piece and spinning the pointer of a 4-section spinner. Does it matter if Sherry starts the tree diagram with the game piece outcomes or the spinner outcomes? Absolutely not. If we got 12 sides here, that's going to be 12 times 4. And that's going to be the same as saying 4 times 12. You're going to get 48 outcomes no matter what. I'm pretty sure I'm going to get this one right. Well, does it matter? It says no. The number of outcomes in the sample space of this compound event will be the same regardless of the order in which the events are listed. The tree diagram will show 48 outcomes no matter what Sherry starts with. Hey, I got that one right. Let's go to the do you know how. Number 4, both spinners A and spinner B have an equal size section. This is true. As shown on the right, it says make a table to represent the sample space when both spinners are spun. Well, it could either be red or 1, then red or 2, then red or 3. It could be blue or 1, blue or 2, or blue or 3. It could be green or 1, green or 2, or green or 3. Well, let's see, come on, that's 3 times 3. I think I'm going to get 9. Well, when we look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. All right, here's number 5. Tiles labeled with the letters X, Y, and Z are in a bag. Tiles labeled with numbers 1 and 2 are in a box. Make a tree diagram to represent the sample space of the compound events of selecting one tile from each container. Remember, a tree diagram is when we start with one of these possible outcomes and then we branch it off. Well, in this case, we're looking at the letters X, Y, and Z. And now X could be 1 and 2 afterwards. Y could be 1 and 2, or Z could be get 1 or 2 labeled after it. So that is going to be 1, 2, 3, 4, 5, 6 possible outcomes. Well, it looks like the practice and problem solving is all that's left, and that's your homework, and you can go to the video for help with that. Good luck, and thanks for listening. Have a good night. Good night.